Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see how to search an element in an array. Fine. Just take for example, this is my array. This is my array, and I want to search whether 9 is present in this array or not. Okay, how can we do this? We can do in a simpler way, like first of all, I want to take this 1 and I want to check whether 1 is equal to 9. No. And then I want to take this 4 and check whether 4 is equal to 9. No. And then I want to take this 9 and checking whether 9 is equal to 9. Yes, it is equal to, right? So just return true. So this is my approach. Yes. Let me take another example. Just take for example, maybe, okay, and then the search element I have given is 10. Okay, first of all we are going to check whether this 2 and 10 are equal. No. 4 no. 7 no. 3 no. 5 no. So what is the answer? It will be false. So this is the basic idea, right? So what is the approach? We are going to traverse through this entire array, and if any one element is same as the search element, then I can say true, else I want to say false. Yes. So this is my approach. So as of now we know how to traverse in the array, but still we can see the code. See here, array is equal to some numbers, okay, some elements, and search element is equal to 9. Now I want to check whether 9 is present in this array or not. Flag variable is equal to 0. I will tell you why I am using this flag variable in later. Just wait. For I in arr, if I is equal to search element, if it is equal to search element, I want to print what? Yes, found. Then I want to make the flag value as 1 and then break. Why I have to do this step? Because we have to know whether the entire array that do not contain the search element. If the entire array do not contain the search element, then obviously this condition won't work, right? The control flow won't go inside this condition, so that I can say if flag is equal to 0, then it is not found, right? I'm checking on every elements in the array. Then if flag value is not equal to 1, initially it is 0, right? If it is 0, I can say not found, right? Okay, many of them do mistakes, like see here, a common mistake everyone does in this problem, like they do not use this flag variable and they give else part. Just see here, they give else part here and then print it. But don't do this mistake, because see here carefully. For I in arr, if I is equal to search, yes, found. If it is not equal to search, not found will be printed. Okay, just see here, not found for 1, and then for 9 it is found and then break statement is executed. So don't ever do this mistake. It is a common mistake. Okay, but in Python we have flexibility, right? We can give this else part outside. What it mean? It means for the for loop I have written the else statement. See here, for this for loop I have wrote this else statement. It means if the for loop do not terminate in between the range, that means if this break statement is not executed, then surely this else statement will be executed, right? So this is the else part in the looping in Python. If you don't know about this, please make sure go and watch my playlist in Python. There I will use this else statement, right? Let me submit it. Yes, fine. Okay, we can change the number as 10. Fine, not found. So this is what linear search. This is what linear search. Okay, let me write here. This is a linear search. Now coming to the second problem. See here, count the element in an array. Okay, let me take an example. See here, let me take 1, 2, 1, 3, 10, 10, 9, 8. Okay, and I will give a element target is equal to some value. Let me take 1. Then you have to output me like, just a second, like output should be whether 1 is present in this array. Yes. How many times? How many times this 1 is present? This 1 is present 2 times. You have to give me the output as 2. Okay, because this 1 is there in 2 times. See here, this is 1 time and this is second time. Right? So you have to return what? 2. You have to print 2. So this is the question. As of now, it is in the shell. So how to approach this problem? Already we have learned how to search in a linear search algorithm, right? We have already studied linear search. Now, in linear search, we check whether the element is equal to what? Search element. Whether the element is equal to search element. Can we make some alternative, right? Somewhat alter the code to give them to give them answer. Just see if a element is equal to this target. If element is equal to target, then I have to do what? I have to count. I want to count. Do you understand? Whenever we are hitting the target, whenever the current element is equal to target, then I have to increment the count so that I will store the count of the that element, target element, right? So see here, ARR is equal to some set of elements. Search is equal to 4. We want to search. We want to count the number of occurrence of 4 in that array, right? Now count is equal to 0 for I in ARR. If I is equal to search count plus plus, just see it is as like as a linear search algorithm. Okay, print count 5 because here are 3 fours and here is a 4 and here is a 4, right? So totally 5 fours. Okay, then and then we are getting into the binary search algorithm. So it is a efficient algorithm while comparing to the linear search algorithm. Let me explain. There are some conditions for writing this binary search algorithm. Binary search. What are those conditions? The first condition is the array should be sorted. The array should be sorted in either descending or ascending. In either descending or ascending. So this is the first condition. Okay. Then we can do whatever the array, we can find the element. Fine. Let us see by example. Let me take an example. 1, 3, 4, 10, 20, 30. So this is my array. Let me take. Now I am asking you to search for maybe 3. Search for 3. Now let me take the index 0, 1, 2, 3, 4, 5. So these are the index of the array. Now see this, observe this approach. I will take this as my low and this as my high. Let me write here. Low is equal to 0 and high is equal to what? 5. This is my first step. Now I'm going to check the midpoint of those. The midpoint. What is the midpoint? How to calculate the midpoint? It is easy, right? Low plus high divided by 2 is equal to mid, right? So this is what we will find the midpoint. Yes. So what is the answer? What is the mid now? What is mid now? Mid is equal to 0 plus 5 divided by 2, which is equal to 2.5. In integer, we will take 2. So mid is 2. Now this is my mid. Let me take this color. This is my mid. Okay. Now I'm going to check whether midpoint is 4, right? Midpoint element is 4. 4 is equal to 3. No, it is not equal to 3. Okay, okay. Then I have to move to this part or to this part to find the value 3. So this is what a next idea I'm just thinking about. Okay, fine. So let us see. 4 is greater than 3 or less than 3. It is greater than 3. It is greater than 3. So obviously, if 4 is itself greater than 3, then how come the elements which are greater than 4 can be my part of my answer? That is, how come this part of the array can be my answer? Okay, so I can say I will reduce the high pointer here. I will reduce this high pointer where? Here. So H, here L. Fine. So just take it and make us 1. What I am used here, I will make the H pointer what? Mid to minus 1. I will make the h pointer what? Mid to minus 1. When I made this, okay, when the condition is, if the condition is what? Mid value, mid value is greater than the target, then I want to do this step. That's what the observation, right? We want to make the high pointer what? Mid minus 1. That's what we have done, right? Now again, what is the mid pointer? Mid is equal to h plus l divided by 2. So what is my l? It is 0 and 1 divided by 2, which is equal to what? 1 by 2, which is equal to 0. 1 by 2 is 0 0.5. So obviously integer will be 0. So my mid pointer will be where? My mid pointer is pointing us this 1. Whether 1 is equal to 3? No. Okay, fine. Whether 1 is greater than 3 or less than 3, so that I can shift whether I want to shift, I want to take this part of the array or that part of my array. Let us see. So 1 is less than 3. So I can surely say the left part of 1 don't be my answer, because it is sorted, right? So that I can say this part, this entire part cannot be my answer. I want to move right side so that I can get the answer, right? I may or may not get the answer, but still this cannot be my answer. So I will make a movement of my L pointer to where? Here, right? So when I move my L pointer, I will move L pointer to mid plus 1 when I hit the condition like mid value is what? Less than target. Yes, yes. Okay, now what is my low pointer? It is 1. Okay, again find the mid pointer. What's the mid pointer? What's the mid pointer? It is 1 plus 1 by 2, which is equal to what? 1. Now my mid pointer is where? At to 1. To 1 in this. What is my 1 in this? It is 3. Whether 3 is equal to 3? Yes, 3 is equal to 3. 3 is equal to 3. So I can say, yes, I found the element. Just return. Right? I'm just returning the element. So it will return what? True. Okay. So this is what the working of binary search. Okay. If the element is not found. Okay. Take for example, here instead of 3, there is maybe like 2. There's maybe 2. Then what should be my answer? Again, this I take it and write here 1, 2, 4, 10, 20, 30. 10, 20, 30. Same array. Currently, my pointer is where? Just assume my low pointer is here and high pointer is also here. Now, listen carefully. Now, my mid is 2. Whether 2 is equal to 3? No. Whether it is greater than 3? No. It is less than 3. Less than 3. If it is less than 3, I have to move my low pointer to one step ahead. See here. Yes, low pointer to one step ahead, right? So move my low pointer one step ahead of mid. Mid is where? Mid is this 2. So I'm moving my low pointer. Now low pointer will become here. Now just observe my high pointer is less than the low pointer, right? Because this is 0, 1, 2, 3, 4, 5. My high pointer is 1, but low pointer is 2. So high pointer is less than low pointer. So I can say I have seen every elements. So I should stop. So until when I have to do? I have to do until what? L is less than or equal to high. That is low is less than or equal to high. Until that I have to do this all step. Once it is terminated from the loop. That means once the condition is low is greater than high, then I can say what? False. Then I can say false because I have visited every elements and there is no element found as like a search element. So I need to write what? False. So this is what the approach. Let us see the code. See here. ARR is equal to some array. Then search is equal to 10. L comma U is equal to 0 comma len of array minus 1. As I said, low pointer and high pointer. Now flag is equal to 0 while L is less than or equal to U. Mid is equal to L plus U minus 1 divided by 2. Why I use this? I have said you that high plus low divided by 2, then why I am using that? Because in Python it won't leads to any error. But if it is C++ or Java code, sometimes integer overflow may occur. Okay, when the element reaches a highest value, take for example, low is also something like 10 power 6 or 10 power 7, and high is also 10 power 6 or 10 power 7. That time, integer overflow will occur. Integer overflow will occur. Okay, so to reduce it, we want to use a formula like L plus U minus L divided by 2. It is float division. In C plus Java, we ordinarily get a integer data type, right? So this is what the mid formula is, a basic formula. Let us see when low is equal to 0. Sorry, let low maybe some values 2 and high is equal to some value maybe 6 maybe. So what is low? It is 2. What is high? It is 6 minus what is L? It is 2 and then divided by 2. So which is equal to 2 plus 4 divided by 2, which is equal to 2 plus 2, which is equal to 4. This is the output I have got for this formula. Let us see for next formula. Let us take, yes, let us take L plus H divided by 2, which is equal to, what is L? It is 2 plus 6 divided by 2, which is equal to 8 divided by 2, which is equal to 4. So I got the same answer, right? Fine. So we want to use this formula so that whenever the value of U and L are sometimes a larger value, it will first do a minus, then I will divide, then I will add to the this L value so that integer overflow will not occur. Okay, that's the reason why I have used this formula. Now, if ARR of mid is equal to search, I want to print what? Found. Then flag is equal to 1, then I want to break. Same logic used in the linear search, right? There also we are using the flag variable to check whether the element is found or not. Fine. Okay. L if ARR of mid is less than search, then L is equal to mid plus 1. Else U is equal to mid minus 1. Because it is sorted and already in ascending order, right? I have already told you the formula here. We have seen this observation, right? This observation. Why? Because it is in ascending order. It is in ascending order. So that only I have written this. You have to find for the descending order, you have to write the logic for the descending order for in a binary search algorithm. If you have faced any issues, then just comment below. I will also put that video in separately. Okay, because in ascending order, this both condition like this, but in descending order, it will be reversed. Okay, that's all about. Okay, then flag is equal to 0. If flag is equal to 0, then not found. Let me submit it. It is not found. 10 is not found. Let me give a value 7. So 7 is found. Okay. Now everyone arises a question, right? Everyone will, while learning this binary search will arises a question like, we already have a linear search algorithm. Then why we are going to the binary search algorithm? Why we are going? Okay. Let us see what are the uses of binary search. Binary search will reduce the time complexity. Reduce the time complexity. But how it reduces the time complexity? Just observe carefully. I have an array of something like names. Okay, names that are in maybe sorted order. Okay, in sorted order. Now I have to find whether a name called Pirai is there in this array or not. Is there in this array or not? If the array size is 10 power 9, something like 10 power 9, it means what? Ones, tens, 100,000, 10,000, lakh, 10 lakh, crore, 1, 2, 3, 4, 5, 6, 7, 8, 9. Crore, 10 crore, 100 crore. There are 100 crore names. Fine. Now we want to find whether this one word is present in this name array. Then we want to traverse entire array. I want to traverse entire array and check one by one whether the name is free. Name is free. Name is free. So totally, how many times we want to check? We want to check for 100 crore time. We want to check for 10 power 9 time. So that only the time complexity of the linear search is O of n. Okay, because if the input is 100, we want to check for 100. If the input is 1000, we want to check for 1000. If the input is 90, we want to check up to what? How many times? 90. You may ask, sometimes we have this array 1, 2, 3, etc. so on. Just assume, and I give a search element as 1. Then we will get in a O of 1 complexity, right? This is what best case. This is best case. We don't take the best case. We always take the worst case. If the element is not present, just think numbers from 1 to 1000 is there. Okay, I'm giving 2000. Then there is no element present in this, right? So it will traverse all this element in the array, then gives the result as not found. Hence, I can say time complexity is what? O of n. Fine. Now let us think about the binary search. Let me take an array like 1, 2, 3, 4, 5, 6. Fine. Now, if I want to find this 2, first of all, I break this array into two parts. Let us take. I will break this array into two parts by taking the mid value as what? This 3. Okay. Now I'm going to check whether 3. I want to go to this part, or I want to go to this part. This is my first step, right? And I will find I don't want to go to this part. I want to move to what? This part. Again, I will split this array by using this mid pointer. So here I can say I'm continuously splitting the array by 2. I'm continuously splitting the array by 2. So I can say if the array size is initially maybe 32, let us say 32, it will split into 16, again 8, again 4, again 2, again 1, again 0. This is the worst case. If the element is not found, this is what the method we will. This is what the iteration we will take. This is the number of elements in the array, right? So just see here. Let me take another color. This is the first step, second step, third step, fourth step, fifth step, sixth step. For 32 elements, I have found in only 6 steps, right? It means just see this carefully. I can say log n base 2. It runs up to log n times because I'm giving 32. What is 2 power 5? It is 32. What is 2 power 6? It is 64. It is running for 6 times, but still it is what? Just 2 power n plus 1, which is equal to what? N, right? So let us take this as t. Then we can say n is equal to, sorry, t is equal to log n base 2, right? Almost approximately. So that's why the time complexity of binary search is log n base 2. Okay, so this is the main reason we are going to use the binary search algorithm. But still, you want to know about still more about this linear search and binary search. Let me take here this linear search is useful when we are handling with the unsorted array. Okay, when we are handling with the unsorted array or some data structures. But this binary search is only used for the sorted array. Okay, and then what is the time complexity here? O of n. O of n. What's the time complexity here? O of log n base 2. So these are the difference between the binary search and linear search. Fine. Thank you.